Alright, today we're doing 6-1 polygon angle sum theorem, or theorems. Right, first thing, polygon angle sum theorem. The sum of the measures of the interior angles of an n-gon is n minus 2 times 180, where n is the number of sides of the polygon. Right, so for a triangle, I'll work this out for you. 3 sides in a triangle, minus 2 times 180. Right, so that's 1 times 180 degrees. That's for a triangle. You can work this out for any number of sides. Okay. This is just a list of all the different types of polygons: triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, and decagon. Right, heptagon is probably one you're not super familiar with. Nonagon as well. Possibly decagon, but the other several ones, you know, what, 1, 2, 3, 4, 5, I'd expect you guys to know. If not, you better learn them. And you better learn the other 3 as well. Okay, so finding a polygon using the angle sum theorem. What is the sum of the interior angle measures of a heptagon? Remember, interior angles will be the inside. So heptagon, we just went over this. A heptagon has 7 sides. So it's going to be, we're using n minus 2 times 180. We're going to plug in 7 for n. So 7 minus 2 is equal to 180. 5 times 180. Oops. Sorry about that. Times 180. That should be times 180, which should be 900. So there's 900 degrees in a 7-sided figure. Right. Next, what is the sum of the interior measure of a 17-gon? So 17 minus 2 times 180. If you guys are thinking, hey, I'll just plug this into the calculator, you could do that, but you need to make sure that you guys put it in parentheses. Okay, so it should be 15 times 180. And I don't have my calculator on me, so I'm going to go ahead and do that out. 15, 180, 0, 0, 9, and then 180. So we should be looking right around 2,700 degrees. And I don't have my calculator, but I will pull out my phone and just check that for you guys. Because I'd hate for this to be here for all eternity and it'd be wrong. Nope, we're okay. Moving on. The sum of the interior angle measures of a polygon is 1,980. How can you find the number of sides in the polygon? So we're just going to invert that formula we were using, or use the opposite of it, right? So n minus 2 times 180 was equal to our degrees. Our degrees is 1,980. I'm just going to divide by 180. Divide by 180, that's a 9 if you guys can't tell. Right, so 1,980 divided by 180 is 11. So n minus 2 is equal to 11. Add the 2 to both sides. N equals 13. So we should have 13 sides, right, for a polygon to have 1,980 in the interior angles. Alright, some more vocab. An equilateral polygon is a polygon with all sides congruent, right? We know that from equilateral triangle. An equiangular polygon is a polygon with all angles congruent. Now, if we have both equilateral and equiangular, we have what's called a regular polygon. A regular polygon is a polygon that is both equilateral and equiangular. right? The corollary to the polygon angle sum theorem, right? So the measure of each interior angle of a regular pentagon is n minus 2 times 180 divided by n. And so what we're really doing here is we're finding the total number of degrees, dividing that by the number of sides, because all the sides, or excuse me, all the angles are the same. So, a common housefly has eyes that consist of approximately 4,000 facets. Each facet is a regular hexagon. What is the measure of each interior angle in a hexagonal facet? So first thing we need to do is... Alright, sorry. I had an interruption. Okay, so what is the measure of each interior angle in a hexagonal facet? This 4,000 up here, you guys, means nothing. That's just the number of the hexagons there are, so not really relevant. Right, what we are going to do is take 7 minus 2, and we're going to times that by 180 to find the total number of degrees, and then divide by 7, right, because that's the number of sides. So, excuse me, hexagon, not heptagon. So, we will be timesing and dividing by we'll be dividing only by 6. I'm new to the software, guys. Cut me some slack. So, 6. So, 4 times 180 divided by 4, 720 divided by 4. That should give us 120 degrees. That's how many degrees are in each hexagon. And now here's the cool thing. That's any regular hexagon. They're all going to be 120 degrees. What is the measure of each interior angle in a regular nonagon? So same thing. We're going to take 9 minus 2 times 180 and then divide by 9. Remember, this means right here 9 sides. So 7 times 180 divided by 9. 7 times 180 is 1,260. So 1,260 divided by 9 gives us 140 degrees for a nonagon. Okay, problem 3, using the polygon angle sum, what is the measure y in a pentagon today? So TODAY. Alright, so this is 90, and we're going to add up all of these and set it equal to the total number of degrees. A pentagon, how many degrees does a pentagon have? Well, what is 5 minus 2 times 180? Well, 3 times 180, I believe that's 540. Just checking. 3 times 180, 540. So 110 plus 90 plus 120 plus 150 plus angle y is equal to 540. Well, let's add all of this together, and that's 200, 120, 150. That's 470 plus angle y equals 540. I'm going to have to move over here. So 470 plus angle y, 540, minus the 470, angle y should be 70 degrees. Alright. Keep going. Same thing. This is a quadrilateral. We should already know quadrilaterals have 360 degrees. Right, think of a square. Square has 4 right angles. That's 4 times 90 is 360. So I'm not going to work out finding all of that. I'm just going to go ahead and go 120 plus 85 plus 53 plus angle G is 360. Sorry. Alright. Add those all together. We get 120 plus 85 plus 53 is 258. So 258 plus angle G is 360 minus 258 minus 258. And we should get angle G is equal to 102 degrees. Alright, a couple more slides. Slides. Alright. You can draw exterior angles at any vertex of a polygon. The figure below shows that the sum of the measures of the exterior angles, one each vertex, is 360. That's for any shape. Okay, no matter how many sides, the exterior angles will be 360 degrees. Notice triangle, quadrilateral, 360. It's always 360. This is the same thing, just written as the polygon exterior angle sum theorem. Alright, so finding an exterior angle measure. What is the measure of angle 1 in regular octagon at the right? Well, it has an octagon, which means there's 8 exterior angles. So all we have to do is take 360 and divide it by 8. Right? So 360 total degrees, 8 angles. Do that, and we get 45 degrees. That's for angle 1. That's also for angle 2, 3, 4, 5, 6, 7, and 8. Because it's a regular octagon, the exterior angles are going to be the same because all the interior angles are the same. What is the measure of an exterior angle of a regular nonagon? Right, so same thing, but we're just going to divide. Oops. Okay, we are just going to divide by 9 this time. So I'm going to go ahead, erase that, make my lines a little smaller. So we're going to take 360, divide by 9, and that gives us 40. So it's 40 degrees for a regular nonagon. Oh, nope. That's it. All right, you guys. Have a great day.